So guys, this is the circuit of Opamp, and as the values of both the resistances here are same, so the gain would be equals to 1. Now we are supposed to do the transient analysis of this circuit, and we have used a function generator to input the square wave, and now we are going to first set the values. Now I want the frequency to be 10 kilohertz. Okay, so 10 kilohertz, and I want my peak to peak voltage to be 3 volts. So for that I will have to select 1.5 as peak value. Okay, and we are going to twice it and it will become 3 volts peak to peak. So 1.5 volts peak. And yes, we are going to select the square wave as we are supposed to calculate the slew rate. Okay, everything is set. Now we are going to move towards the toolbar and look for the option simulate, analysis and simulation. Okay, transient analysis. Here we will have to select a range for the time. I want my analysis to start at t is equals to 0, and I want it to get end at 1 milliseconds. Okay, so 0.001 seconds. I will have to tick this checkbox here, maximum time step, and the value will appear automatically. We will just leave it there. Now as I run the circuit, it is going to show me an error. We will talk about it. There are no valid output variables. So for this we will have to actually generate a variable. And how are we going to do that? We are going to right click on the portion where you are making the circuit, and then place on schematic on page connector. Now you can give it any name. I'm going to give it a name V out. Okay, now you are going to connect this output parameter to the output of your circuit. Here I am going to take the output from pin number 6, so I am going to connect it there. Okay, now we are going to open the same dialog box. Transient, maximum time step should be selected. Now output. Here we are going to select the output variable that we have just named. I named it V out. Add. Now let's run the circuit and check. This is the square wave that we needed. Now as we are supposed to calculate the slew rate, so we need cursors so that we can take the difference between the voltages and times respectively. So when you are going to right click on graph view, there would be option of show cursors. Now these are the cursors. So you have to make sure that you place the cursors in the linear region, okay, like it is a ramp signal, because you want the slope to be constant. Now we are going to note the values for y2, y1, x2 and x1. Here are the values: y2 2.5549, y1 minus 2.5314, x2 is 167.4566 microseconds, and x1 is 151.658 at microseconds. How are we going to calculate slew rate? So this is the formula for the slew rate. Here the values of y2, y1, x2, x1 are required. We are going to get them from the graph view. Y2 is 2.5549, 2.5549 minus y1 minus 2.5314, which will make it positive 2.5314, 2.5314 divided by x2. Here is 167.4566. 167.4566 minus x1, which is 151.6588. Now we are going to calculate it through a calculator. So here we are going to get a slew rate of 0.3219 volts per microseconds. That's it from the video. Thank you for watching.